what features and capabilities that they actually invest in. So Mentor Graphics has created these pads options, as Kyle was talking about, to actually give this analysis capability to our pads users on the desktop, kind of a lower entry point when it comes to that investment. So I'm going to show you the feature set in that. And I also want to wrap up too that maybe I make a distinction between the features of the pads HyperLynx DDR and the HyperLynx SI DDRX. If I don't answer all your questions, which I suspect might be the case, I want to encourage anyone to reach out after this webinar. Send that email to the contact people that Kyle mentioned there, and we can have a further discussion. We could go in and do more of a detailed demonstration as needed for you or your team, right? Or certainly, as Kyle also invited you to, maybe you want to do a product evaluation, because it will be Kyle and myself that will help you with that evaluation. So we'll wrap up in that manner. So looking at my next slide here, when we talk about the pads creation platform, right, this is really the schematic entry layout tools. So you have DX Designer for the schematic, we have pads layout and pads router, and what's connected in that platform is all these other facilities and tools to help you get that product out the door quickly. So we have data book for data management, we have constraint management, so you can put your constraints into that spreadsheet and drive the printed circuit board process. And we also have links to other capabilities for design for manufacturing and ECAD and MCAD collaboration. So it's an entire suite of tools. Looking at the next slide, here's where this has been enhanced over the last couple of years, where we now bring more analysis tools to the engineer's desktop. Today we're going to focus on the DDRX Analysis, shown at the bottom link here. And as I mentioned, the pads HyperLynx DDR, what's the feature set that you get if you add that to your particular platform? There's some other tools connected with this. At the top left, Kyle mentioned that the next webinar series will be discussing pads HyperLynx DC drop. So you get more information about that. If you want analog mixed signal, for example, you can add pads AMS to the design suite. And all of these analysis tools are tightly coupled into the pads creation platform. And you'll see that when I demonstrate this flow, how they're actually connected. Down in the lower right, hopefully you can see that. That's the electrical design rule checker, and we call that pads HyperLynx DRC. Very powerful tool to help you look for physical characteristics of your board known to cause electromagnetic type interference. And we've had webinars on that. Certainly that's something we can engage with your team if you need to know more information on that. Okay, so signal integrity, it's important to know, you see on the right-hand side, if you have a pad standard plus for your license, you do have some signal integrity capabilities from HyperLynx within your tool already. So I'm going to try to remind you of that and show you what you get. But today we're going to focus on these other two, pads HyperLynx DDR, which is an option that you can get, or you could also get the standalone version, which is more powerful, HyperLynx SI DDRX. And again, it's the same software, but I'll show you what you can do with those particular features. So when we're talking about signal integrity analysis and what you get in the Pad Standard Plus, you do have the ability to view waveform shapes once you do a simulation of a trace. And you can determine the effects of your edge rates on that signal characteristics. Because we want to design impedance-controlled circuits to minimize the discontinuities and the distortion. All that capability exists in HyperLynx SI, and you get much of that in the Pad Standard Plus. The reason this is important, right? Engineering teams need to study the impact of their decisions as they're going to design and develop this board. What's the effect of the trace parameters on your signal integrity? What's the effect of the topology? For today's discussion, we're talking about double data rate memory interfaces, and the topology of that is important. That has a huge impact on the signal integrity and whether that interface will work properly. The technology, what is the speed of the the edge rates, for example, the technology of DDR2, DDR3. It makes a difference. We need to understand that. And the other thing that's very important here, as engineers, we do bring our experience, our rules of thumb, figures of merit. We read design guidelines, and that's all very important as we figure out how am I going to approach this design, build this product, build this system. But it's also very important that we incorporate simulation and analysis, and you'll see that with the pads Hyperlinks DDR. Now, I also want to invite everyone interested in these slides. I'll make sure they're available. You just certainly have to ask the Oasis team. So some of the slides in here, I'm just going to highlight a few. Others are included just to kind of help with your understanding and clarification. So for those of you that are brand new to Hyperlinks and never have seen it before, we do have two editors in that tool. One's called Hyperlinks Line Sim, shown on the left, and this allows you in this editor to create the interconnects of your transmission lines as you're proposing to build them. And here's where you develop your constraints, like how long can a trace be before I have a timing problem? How closely can I put the trace elements together and still meet my crosstalk limits, for example? And that information we can capture in your CAD tool and drive that printed circuit board routing. The Hyperlinks board sim is shown on the right-hand side, and this is now all the data from your CAD tool, which is a push-button operation, and now you have your stack up, you have your component placement, you have all the routing, you've done a lot of work, and now this is exactly how you propose to build your board. But this is a good time now to do a final verification. Let's validate that the signals look clean. Let's validate that DDR3 interface that we took such care to route. Let's make sure that works, and that's what we provide with the Hyperlinks tools. Okay, if we look at the double data rate, if you're new to that, let's look a little bit at the system here. I'm showing the block diagram with the DDR controller on the left-hand side and your DRAMs, your memory modules, to the right-hand side. At the top, we have a data bus that also has a DQS, which is a data strobe. That's how we strobe in the data. At the bottom, we have the address, we have the command, the control, and the clock. The data is bidirectional, and the address is unidirectional. So a little bit about the characteristics of each. The controller is actually the main function of the system. It's typically the larger physically of the devices there, and it's more expensive. More money is spent on the controller, especially as you move up in complexity from DDR2 to DDR3. There's now DDR4. And so there's no industry standard on how that controller really behaves. The DRAMs, though, on the other hand, they store and retrieve the data. They're very cost sensitive, so they don't want to spend much money on those. And the key thing there is they are standardized by the JADEC spec. So in Hyperlinks, we have the JADEC specs and the timing for those memory modules, and we use that for our simulation and our analysis. Now, a couple of things that are important to note about the double data rate memory interface. First of all, the data, let's look at the top right here. The data that runs from the controller to the memories is actually has a strobe that follows along the same path. And data is clocked in both on the rising edge of that strobe and the falling edge of that strobe. That's why they call it double data rate. If we look at the timing model or the waveform at the bottom here, as the strobe goes up, that data bit would be clocked in, and as the strobe goes down, the next bit gets clocked in. And with this synchronous data interface, the data is grouped together and coordinated by the strobe, and those data groups can be 4 bits wide, 8 or 16 bits wide as well. For the dynamic RAM at the receiver, again, those timing specifications are set by the JADEC spec, and so there it's very critical that we look at the setup and hold times of the reads and the writes, and so that's specified by the data and the data strobe, the address, and the clock strobe. There's a lot of details associated with the timing of this, and we incorporate all of that information in HyperLynx SI and make your job easier for you. So I think it's important to talk about the challenges of the DDR to introduce some of the key words associated with double data rate. And they're identified on the left. And I'm going to talk a little bit on a slide on each one of these. I mentioned flyby topology, right leveling, what that is, why it's important. Slew derating, something that allows us to adjust our timing parameters for that interface. We have the concept of on-die termination. And we want to wrap all that together because we want full timing analysis of the entire bus, the interaction of all the signals operating simultaneously, and say, can we meet the JDEC spec given our board routing and our controller intelligence. The screenshots on the right are actually taken from, actually put those in there this morning. It's actually showing information that's on Mentor's support net. So if you're a Mentor customer, or if you become a Mentor customer, you will get access to a lot of application notes, tech notes. And here I just thought I'd put a little screenshot in there. If you are new to these interfaces, we have tech notes that are just focused on the terminologies and the topologies, right? So depending on what you're targeting, it's a great place to start. Go in there and see what Mentor has for you to get you going. And we have sample designs as well. Okay, let's talk about flyby topology. And we're showing actually two architects here. The DDR2 shown on the left-hand side, the red arrows are the data and the data strobes. And what we're showing is they are tied directly from the controller and they're routed directly to the data modules themselves, right? So all the lengths are the same, which kind of makes that easy. With the address, we're pretty much doing the same thing, shown in the black here. So the distance to all of the memories from the controllers, right, are roughly the same. And so we're able to do that at the data rates and the technology used for DDR2. But what has happened is when we move to DDR3, what happens is the data rates go faster, the voltage margins get smaller, and therefore we have new signal integrity challenges that we didn't have previously. So we have to come up with new methodologies to make that work. So what's done with DDR3 is the data routing remains the same, but now the address is going to be routed in, some people call it a daisy chain or flyby. So the address is going to go to the first memory device first, and then down to the next one, and then to the next one, so depending on how you have. The challenge with that now, as you can see, the time it takes for the data to get to the device is much shorter than the address. And that's kind of unpredictable. So we need a controller that's smart enough to recognize this and compensate for that. That's why you're finding the controllers are more expensive. Over on the right here, we're showing this. What we don't want to do is lengthen the trace of the data to try to compensate for that. That's not the approach that we're going to use for that. So right leveling is another key word in the DDR language here. And this is the concept of where the controller is smart enough to recognize this difference where the address lines have been routed in a longer length. And the controller can get some feedback on just exactly how long is that delay, and the controller is then smart enough to say, good, I'm going to adjust the timing of the data and the data strobe and compensate for that. So that's called right leveling. So as I'm bringing up these topics, you can see more and more what we're going to be looking for HyperLynx SI to do for us to make sure that our interface will work properly. Another thing we have is slew derating. And we're showing signals that are at the rising edge of a signal. And if we look at the green one, you can see the green peaks at the input voltage high, right? And that's fine, right? And that means, okay, great. The signal has reached its input voltage, and now it'll switch and read the right logic level 1 at the chip, for example. But the slew derating gives us an opportunity to actually adjust our timing parameters, because it takes more than just the voltage of the signal to reach that input high voltage. So as an example here, this slew rate in the red, it goes up so fast, even though it would reach the input high voltage, that has yet not had enough charge to actually switch the gate. So therefore, we have to delay and add some time to our timing numbers and make sure that we get the full charge that we need. The opposite of that is if we have a slew rate that's really slow, right? And as we find, the way we routed the board. So if the slew rate's too slow, it's taken a long time to get up to the input high voltage. But we actually don't have to always wait for that if we have enough area under the curve, which represents a charge. And so this is the concept of slew derating. So each signal needs to be looked at in this manner, and then we can adjust the timing. So that's a lot of signals to look at. That's a lot of information to characterize and then figure out, do I need to adjust the timing numbers? So here's an example of actually looking at a waveform shape on the right-hand side. And you can see as the signal is going up, it's not always continues with the same direction. And that could be an example of what we just talked about. What if the slew rate's too slow? Do we really have to wait for this to get all the way up there before the data is valid and we can clock it? And the answer is like, no, we don't have to wait. So we look for these delta T times. So this is more of some of the topics that you want to understand as you look at the double data rate memory interface. That's called slew derating. So the big picture is in Hyperlinks SI, we have a DDR Wizard that once we get into board sim, we're reading your board data layout, and then we can assign the IBIS models for the controller, for the DRAMs based on the technology, and then we can run a simulation and we'll get a pass and fail criteria. The simulation also produces lots of comma-separated value files so we can look at the waveform shapes. We're showing at the top right of my slide here, there's a column in there that will tell you if you failed or not. Color codes it red. And then if there's an error there, we could scroll to the far right and go find the timing parameter or crosstalk number that we violated, whatever it happens to be. So Hyperlinks will capture all these details, identify where the failures are, and then we can roll up our sleeves and go dig a little bit deeper and figure out, hey, what's going on here? What do I need to fix? And of course, we can view all of these waveform shapes, which is shown here in the waveform viewer. So this is very powerful that we use the DDR Wizard and Hyperlinks to help us along to fill in all this information. This, I think, is my last slide before I start the demonstration in the tool. This is the part of the graphical user interface as we walk through the wizard. And essentially there's 4 components of this wizard, right? The first one is we got to specify when we bring the board into board sim, identify by reference designator which components are controller, right? And then which ones are the dynamic RAMs. We do that, and then we go to the next part here and say, okay, which nets do we want to simulate? So we want to make sure that our naming convention of our schematic is actually indicating that the DDR nets are properly defined as address and clock and command. So you'll see that in the demonstration. We also then have to set up the behavior. What on-die termination schemes and models are we going to use? What's the behavior? When the controller writes, am I going to enable or disable the on-die terminations on which end? Do I want to incorporate write leveling, for example? And then finally, we specify the simulation options, and that dictates what reports we're going to generate and things like that. So with that, let me launch the tool, and then I'll get back and wrap up with the presentation. I'm actually going to start from PAD's layout here. And let me begin this by just kind of showing the flow. How do we get into Hyperlinks? So let me just bring up a sample design here from PAD's layout. This happens to be a reference board. Oh. There it is. Okay, you should see that now. So I'm in PAD's layout. It's very convenient under Tools, Analysis. And at the beginning, we talked about those various Hyperlinks options that are available. Today, it's the DDR analysis. So if you invested in that option, you could merely come here, click on this. It's going to take our CAD data, push it over to Hyperlinks bring us into BoardSim, and we can actually run the DDR simulation. I'm actually going to do that process. However, many customers actually have a standalone seat of HyperLynx SI as well. And in that case, they would come and launch this. Essentially, you're launching the same tool, but you're picking out a different license, right? So it's a little less costly to get the DDR. So if you just wanted to start there, that's what you would do. So let's just take a look at that process and see how you would do that. Because I have Hyperlinks installed on this machine, of course, along with my pads, it'll bring this right up, bringing these tools to the engineer's desktop. Okay, so here's Hyperlinks BoardSim. The other thing I'd point out, I'm actually working with a beta version of Hyperlinks, and that shows the power that I can actually link or register with my pads creation platform. What version of Hyperlinks do I want to work with? Maybe there's a new release that comes out, you want access to the technology, I can link that together here. So I'm going to show you where you would launch the DDR Wizard. It's from this pull down here, run the DDR batch simulation. It's going to bring up the Wizard. Okay, and here's where you would begin to read through the details. Notice here it says the Wizard allows you to set up single DDR, DDR2, DDR3. It doesn't include DDR4. This is one of the differences between the standalone and the pads Hyperlinks DDR. So if you were going to do DDR4, you would need that higher licensing level, for example. And what you do as a user is you go through here and you say, okay, let me pick out my technology, let me pick out my data rate that I'm working with, and we would step through this Wizard answering the questions on the right-hand side. I'm going to walk through this on a different invocation of Hyperlinks, but I wanted to point out just a couple of things here. When I bring the CAD data over from pads, of course, all the stack-up information is here as well. Hyperlinks is a 2D field solver. It's going to run the simulation. It has all the information it needs from your CAD tool to do the analysis. So let me just close this. Now let's say we had a standalone version of Hyperlinks, right? I would launch this. Very easy process. Same thing comes up. Okay, and I get the same thing here. Now the difference is, I just wanted to point this out. If I go to Setup Options, License Status, right, this is showing me all the feature set now that I have. I actually meant to show you this screenshot when you had the pads Hyperlinks DDR. And in that case, in the pre-layout shown on the left, there's no features available with that license for line sim. That's a key distinction, right? There are a few here with the post layout. We would have had a few of these actually highlighted and made available, and I meant to show you that to show you the difference. So really, you have access to multiple license features depending on what it is. You might work with a customer or a company that you have a full license of Hyperlinks SI. Depending on what you do, you might want to launch pads and pull out that full one, or maybe you just want to use one of these pads options, so you do have some choices. And then finally, the last thing I'll show here, and then we'll get into the Wizard. If I want to run Hyperlinks standalone, I can just double click on my icon here. And this is actually launching Hyperlinks here too. And then I can bring up the board file that was created when I exported that from pads. So I'm just going to do that right here and then show you the Wizard. So there's a lot of different ways to launch this. You have choices, kind of depends on what you want to do, what's the role at your company. But you can see it's all very tightly integrated. So now I'm working with Hyperlinks 9.4.1, the very latest release of Hyperlinks here. So immediately, since we're focused on the DDR, here's what I would do first. I bring up the DDR Wizard. So you recognize this. Now, the first thing here, notice this has the DDR4. So now I'm using a more powerful license, right? Because the DDR4 is included. And as a user, I would step through, as I started to show you with that, Once you step through, you can save these settings as a configuration or an initialization file. And that's important because as you go through, you might just want to have some real simple configuration just to make sure everything's set up, the models are working, and you got a couple of nets working and everything's fine. Later on, you're going to probably set up a configuration file that's the full interface, and now you can use that as regression testing. So in that case, you can say, look, I want to go back and import a configuration file that I had set up before. So let me just load this one in for this particular example. And now I've loaded in all the settings that I did in the previous time. And now as I step through this, I can see what these settings are. This happens to be DDR3. Data rate is 800 megatransfers. If I go to the controller or I hit next, right, it steps me through the wizard. Here's earlier where we defined what is a reference designator for your memory controller, right? So this happens to be U5. If I go to the dynamic RAMs, right, what's the reference designator for the RAMs that I'm using? And you can have multiple configurations of this, how many slots and ranks that you're working with this configuration, because not everyone's doing the same configuration, of course. Then we can define the IBIS models that are being used for your controller in a dynamic RAM. In this particular case, we're using a reference file to actually assign the models. So I can have access to that reference file, which is a text file. It shows me what reference designator is using which IBIS model. So all the modeling is taking place in that particular dialog there. And stepping through this a little bit more, look at all the options you have available here. In this case, we're going to do both the reads and the writes. But maybe when you first start, you just want to focus on one particular cycle. So again, you could store that off as a configuration and come back later to that. Do you want to incorporate the skew that's found between the clock and the strobe? We can specify, turn it on, turn it off. Or do you want to include a wait state with your timing? Do 2T timing instead of 1. And then here's the naming conventions, right? Let's make sure that the net names we're using in our schematic actually line up with the DDR interface. So here you're actually validating that your naming convention actually looks correct. Disable nets. When you get to the simulation component here, I'm going to simulate all the nets when I run the simulation. But at the beginning, you just might want to pick a couple of nets so you could uncheck some of these. How about the on-die termination models? Here you get to specify the device, the component, right? Here's the controller. When the on-die termination is disabled, what model do you want to use? So depending on the sophistication of your controller, you can pick from all of these drive strengths and things like that. How about when the on-die termination is enabled? What do you want to do and what model do you want to use? So you set all these up for yourself. Here's the behavior. I mentioned this earlier, right? As a designer, you have to make this work both when the controller is writing and when it's reading, and the configuration of the ODT selection is different based on the operation you're doing. IBIS model selection, a lot of details in here. Another thing that's important to understand is when you're looking at the timing models, as I said, the timing for the DRAMs comes from the JADEC spec. But your controller comes from your FPGA or some other device. So you want to make sure you put in the appropriate timing parameters associated with your controller. By default, we do include controller timing, so you can start with that. But here's another timing wizard. Click this button, pick your technology, and then I can walk through this timing wizard to help us figure out, okay, based on the timing data sheet, what do I want to use for these timing parameters? And it walks us through here to make sure we're entering this in the proper location and everything works for us. Now I know this looks like a lot of details, but what I want to remind everyone that Mentor Graphics support has a lot of application notes associated with this. And they have design examples so you can work through those with their data so you know what information to put in. You follow the instructions, you can see how the simulation goes. So at first it might seem a little overwhelming, but this is a very comprehensive memory interface. And it only gets harder as you go from DDR2 through 3 and to 4. The right leveling, since this is DDR3, the right leveling is that adjustment that we talked about, these address lines that take the longer routing. Well, we can run a simulation, and if we get the timing information and select this option, this allows us to look at a previous simulation where we actually determined the additional delay from the address line to the memory chips. So it's very sophisticated, and all that technology is supported in the Hyperlinks DDR Wizard. If we want to incorporate some crosstalk, we can make those selections here. It makes the simulations longer, but remember, we can do this iteratively, right? Maybe at first you just make sure it works, then later on you turn on more and more capabilities, so you do the final regression testing. If you made changes to the board, right, then you can bring the board in and then just run the test for the regression testing. And then finally we get to the simulation options. Here's an example here too. IC models often have corner cases with their drive strength. So if you want to simulate all three of them, you can specify that here. It's really your choice. Reporting options. We create HTML reports. I'm going to show you that when I run the simulation. And then if I wanted to save the setup data, I would click this and give it a new name and actually do that. Let me just take a minute here to actually run the simulation. This shouldn't take too long, but I want to show you the complete process here and then the information that's actually created. You know, as this is running, what's very important, you'll find that with all the slew derating and all the technology in this interface, it requires thousands of measurements. And now you can get the details of all those measurements in a nice report form, and you get a nice subfolder of the simulation that you can go reference to actually look at these waveform shapes and review the reports. So that's a great way when you go to your design reviews, you know, and show the team, you know, here's our DDR3 memory interface, here's the results of the analysis, and you can actually show them a report that said everything passed based upon the specs. We're finding as well that engineering teams often have to show their customer that they've done some type of analysis. So you're seeing that incorporated in more and more of the Hyperlinks tools, the ability to actually incorporate those reports. So here's the HTML report that was just created. It's got our title here at the top. It has the date and the timestamp. And then there's several columns here that I can select from each column. If I hit the right here, I can scroll down, and then it's actually showing me the writing for each of these transactions and what the signal was. It looks like we passed all of those. If I go to the data read, notice quickly I can look at the status. Oh, I had a couple of failures. Here's one that failed for data bit D8. And I can scroll to the right and find out what kind of failed. Over here, if I look at this pull down, I can actually specify what other details that are associated with this interface and this report that I want to include. So I can include all of these various timing parameters that I want to take a look at. So it's really powerful, right? Not only did it do thousands of measurements, right, but now it's putting it in a form that we can quickly look at it and say, okay, I've identified an area there that needs some work. I can do the same thing with the address, the differential nets, and then here's the timing information between the address clock and the data strobe, right? There's relationships there that have to be adhered to. Now here's another thing that's very powerful is the fact that you see these timing numbers here. If I click on this, this will actually take me right to the simulation database where actually that timing measurement was made. And it shows me graphically those two waveforms, right? So I can view what it actually captured and recorded. Now I'm viewing this in the EasyWave waveform display. So what's important to understand is you need the full standalone version, the Hyperlinks SI-DDRX, to get this type of capability. So if I was only running with the PADS Hyperlinks DDR option, right, I would still get this report, but when I go here to actually invoke the EasyWave, that wouldn't be available. So again, it's just really a matter of upgrading your license to get access to that feature. And I think this is what's important too, as follow-up to this call, if you needed to better understand some of these details that make up the difference, gives you a better opportunity to kind of weigh the trade-offs of which way you might want to go directly with that. Okay, so that's actually running the wizard. You can see it's pretty simple in that form, but the idea is to kind of help you as it interviews you. You can fill in the information based on your interface, based on your net naming conventions and your reference designators and all that kind of stuff. And then you save those off as configuration files. So you don't have to do that over and over again. And as a reminder, if I haven't said this more explicitly, you could actually route your DDR3 interface first on your board and then move this into board sim and run the wizard while the designer continues with the board. So you can kind of work with this interactively, kind of in real time or in parallel as you do that. Okay, I wanted to point out a couple of other things that are important for the debugging of this. It is possible, right, when you first bring in your board, you want to run that DDR Wizard immediately. That's possible. But what people like to do is work a little bit interactively. So I wanted to just highlight that. Here I can bring up the select net by name, and I'm going to filter this by DDR, which is what we're working with today. And if I apply that filter, now I'm just looking at those net names that have the DDR in them. And let me just go to one of the data bits. If I hit D6, I can select this particular net. Let me just clean that up a little bit. Okay, so it highlighted that net in our board, the way it's routed on the various layers that it's routed on with the V, as you see all that. And I could run a simulation right here. If I did not have the models assigned, which is likely probably the case you have right now, I could simply bring up this component models dialog box, and it identifies the pins on this net where I can actually select the pin and make a model assignment. This is just as easy as you work within Line Sim. So again, for those that are not familiar with these tools, right, Line Sim is that pre-route editor to help develop the constraints. This assign models dialog box is in there. So assigning the models to this net here is just the same way we do it in Line Sim. There. So that's just real easy to do. And then I can bring up the digital oscilloscope, and if I wanted to run in a simulation, I can do that with the falling edge, right, and look at the waveform shape, or if I want to do an oscilloscope or oscillation, I can look at that as well. And that's considered interactive analysis. The other thing to keep in mind is I can actually include more than one net there. So if I wanted D6 and I wanted to include D7 and D4, it'll highlight those for me automatically. And again, I can assign the models. We have this thing called Manage Assigned Models. And notice it's identified all the pins on the nets that we've selected. And I can change the model right here and run a simulation. So you can see it's real easy to probe in this virtual environment to actually go in and look at your critical nets. And I can do this before I run the wizard. Right? You wouldn't have to, but this is typically how somebody might approach that. Now I'm going to simplify this a little bit more. If I wanted to add a net here, I could right mouse button, say let's include this. Right? At the same time I could say, hey, I want to exclude something that I've already selected. Right? And what I want to do here, I'm just going to pick and select D6 where we started with. But what I wanted to show you also is the powerful crosstalk capabilities that are available. Under the setup, I can say I want to set my coupling threshold. And I can do that with either an electrical threshold value. So the 2D solver will run in Hyperlinks, looking at the models assigned to the aggressor traces on adjacent layers, top, above, below. And if it will exceed this 30 millivolts, it will show up as an aggressor. Or if we want, we can look for it based upon some spacing distance or minimum distance from our victim trace. I'll just go with the electrical, click OK. And then if I turn on the enable the trace coupling, I can either do it this way or set up here and enable the coupling threshold. The solver runs, and then it found those traces that would be considered aggressors based on our electrical threshold. And I don't know if you can see on your end, but the aggressors have the dashed white line through them, and you can see D6 is a solid. So we're seeing a difference between the aggressors and the victims. And this is very powerful because now, again, in a virtual environment, we can look around our design in ways we just couldn't before without a tool like Hyperlinks. So it is very powerful. One last thing I want to show you here. Let's say there was an issue with our DDR interface, right? We ran the wizard, we had the failures, we do a little probing here and said, okay, D6 has an issue with it, we need to fix it. You know, it could be a number of reasons why it's an issue, right? But in order to figure out how to fix it and what we might want to do to get it to work, a lot of times we want to export that net back into line symbol, also known as our freeform schematic. So I'm going to show you what that process is here. And I'm going to keep this coupled segments unchecked. So I'm going to do this export twice. First time I'll keep it unchecked. And what's going to happen is it'll bring up line sim for me. It'll provide all the data that I need. That means the stack up that's in board sim, which came from your design in your CAD tool. It's got the routing of that particular trace. Notice the D6 here with the model already assigned. It has the vias. So if I double click the via, I can look at how the via is designed, right? Hyperlinks automatically creates the electrical model that would be used to define what the signal sees and how it behaves as it goes through that via. And I can run a simulation here with the oscilloscope, just like I could before, right? And if I had an issue and I thought I knew how to fix it, I could make the adjustment here and prove to myself we found the fix. And maybe that's changing the length of the traces or something like that. Maybe something with the impedance, whatever it happens to be. Okay, and then we would open up our DX Designer or our pads layout, make that fix wherever it needs to be made, and then fix the board. What I want to show you is sometimes we need a little bit more information. So sometimes we want to export the net, and this time let's include the coupling segments that exceeded our threshold of 30 millivolts. It only takes a second here, and then we're going to be in line sim, and now we're going to have more data, but maybe the crosstalk was actually creating the issue, so we needed to look more carefully at that. Now, I know these schematics can look a little bit busy, but let me just kind of zoom in here to show you. We still have our data bit D6, but it also brought in these other nets here too. If we look at this model, this is actually defined as an input. Right, if I want to, because it's bidirectional, I can define it as an output, right? It was just taking the model assignments from our board, right? But what I'm showing is we can create these scenarios that we can go in and say, okay, I want to run a simulation on D6, but now I'm going to include the effects of the neighboring traces that exceeded that amount. The green dashed lines here, for those that are new to Hyperlinks, this is showing me that this small segment of this trace, D6, is actually coupling to the other traces. So I can double click this and then view into this layer here. This is on layer 3, and these are the neighboring traces that are creating some type of coupling. And on the right hand side, I have all the details associated with this, right? How far is it to the next trace? And it actually has the level. I know what layer it's on. So again, in this environment, it's extremely powerful because now the engineer can turn all the knobs that he needs to, he or she, to figure out how am I going to solve this issue that I had with my interface, right? Was it something with the constraints? Did we have that defined improperly in our DX and pads flow? Did we implement it incorrectly, right? What was wrong with our assumptions? Something like that. Okay. So I see it's like 20 after. So that brings us to the end of the demonstration there. I think I hit the highlights that I wanted to show you. Let me go back into the presentation here. Okay. So a little bit review of the licensing here. I mentioned, of course, the pads Hyperlinks DDR. That's an option that you can add to your pads creation platform, right? There's the part number, right? And that gives you the capability to use the wizard in board sim. Doesn't give you any line sim capability, right? We also have a version of that that's called the DDRPE. That has the same functions as the PADS DDR, but this is used for if you're using non-Mentor tools like Altium, Allegro, Zukin, something like that. So it gives you the same capability just in BoardSim, right? But you're not working with pads. So that's how Mentor has partitioned that for you. And then if you want the full-blown license features for the DDR4, the Easy Wave, and things like that, then you would be a candidate to get the Hyperlinks SI DDRX. And there's no restrictions with this, right? It can work with the foreign flows, it can work with pads, so there's no issue there. On this slide here, just as a reminder, what is the difference of those two options, the PADS Hyperlinks DDR and the DDRPE? What is not in that's in the standalone? So you want to remember the DDR4. So when you're working with Oasis and you're doing DDR4, right, you would not be able to do that technology with the PADS Hyperlinks DDR, but you can do it with the standalone. The Easy Wave waveform display is critical if you want to bring up those waveforms that I showed you that are tightly coupled with the report. And then finally, this debugging capability to go from BoardSim to LineSim, very powerful. You would also need the standalone version for that. Again, the licensing level that I wanted to remind you of. Okay, final summary here before I give the floor back to Kyle. We talked about the PADS creation platform, right? It is a suite of all those tools, but they've been expanded so we can get into these other domains like thermal analysis, analog mixed signal, signal integrity, power integrity. Why is that important? Because that gives us the view, the early view into our design. How is it going to perform? How are my engineering decisions affecting the cost? Is it going to have an impact on the schedule? If I approach my design in this way, will it give me a better quality product? So all the companies and the engineering team are prioritizing these, and they have different importance to different people. It depends on where their products fit and the environment that they're in. But everybody wants to get these designs right the first time. So these tools will help us do that. As I mentioned, I can make the presentation available to you, and that's why I had those extra slides in there. My request there is just reach out to your Oasis team. Here's some of those numbers and contact info that Kyle mentioned earlier, so you can reach out to them. If you wanted to do an evaluation of any of these products, not just the PADS options or the Hyperlinks, it could be anything else that Oasis represents, reach out to them. If you're going to do specifically an evaluation of the PADS DDRX, we have, for an example, evaluation tutorials. This one, I just put this screenshot on there. This is 39 pages, comes with the database. It'll walk you through the details. And if you think that would be helpful for your understanding and the concept and the flow, right, it's a great way to really get quickly to that point like, okay, I have a good understanding of what's required to put in, what the simulation looks like, and what the results are going to do for me. And we can do the same thing if you wanted to evaluate the Hyperlinks SI DDR. It's more full featured rich. We have other tutorials that might be more helpful there for you. Finally, here, last couple of slides here. We do have on-demand training, which is very popular, and we do this for most all the tools now at Mentor Graphics. And I brought up and I took a screenshot today of the on-demand training that's available for the Hyperlinks. And I noticed that there's now new chapters added specifically targeted for the double data rate memory interfaces. So if this is new to you and Hyperlinks is new to you, you can sign up for the subscription. You can work with Oasis to get details on that. And you go to the website and you view these little chapters. They show you maybe a 5 or 10 minute video on using hyperlinks in this interface. There's a knowledge-based questions. They're very, very good. And these are the new chapters. There's already been 25 chapters on using board sim. There's been chapters on your stack-up design, termination strategies, series designs, lots of content. But since this topic is DDR, you can see mentors helping you with that, kind of get started. The other thing I wanted to also tell you is if you go to mentor support, there's a mentor recommends website there. You need to support that account. But we have these links that kind of take you directly to some of these technologies. Right, here's DDR2 and DDR3. I'm just going to bring that up because I actually saved that here. So this is my SupportNet account. I'm logged in and I hit that mentor recommends and I said, let's take me to that DDR2 and DDR3 design. So what they've done for us here is co-located all of the app notes associated with this. So you need help getting started. Let me just zoom in a little bit. Here you want to get a little more detail on setting up IBIS models for your DDR Wizard, preparing for your memory controller on your FPGA, the tech note for that. So you could start by downloading these documentation, right, and working through these details to figure out, okay, what do I need to do to get ready to validate my design? So my message here is you're not on your own. There's a lot of content available to you. All this SupportNet stuff is free, and you'd certainly work with Kyle. We probably have more information. We just need to know what you're looking at. So finally, before I turn this over to Kyle, I want to thank you for your time, but this is my contact information at Mentor Graphics. I am on LinkedIn, and I encourage you to connect with me if you're interested. I am located in Maryland, but I do cover and support the distributors all across USA, Canada, and also in Brazil. So Kyle, I am done, and I will give the floor back to you.
All right, great. Thank you, Mike. So I do see a couple of questions that have come in, and we will definitely get to those. Some of those we'll just reply to via email, a little bit in depth of questions, but that's all right. So just a quick recap on HyperLynx DDR. Very easy to use wizard. Does guide you through all the steps and allows you to follow those JEDEC standards from your design to simulation and really feel comfortable about that design working the first time that it's created. We are offering a promotional code for 25% off now of the PADS DDR option. So if that sounds interesting to you, give us a shout out at that phone number or sales@oasissales.com, and this promotion code will allow you to utilize this discount. Okay, and then the last thing I think I'm going to talk about is just our next Did You Know webinar series for our HyperLynx DC drop. Again, allows you to analyze your power distribution network and make sure there's not going to be too much voltage drop on your power planes. Okay, well, thank you very much for attending. Again, I do see some questions coming in, and we will address those via email. If you have any other questions, please feel free to reach out to us at Oasis Sales or Mike as well. So again, thanks, Mike Ashbaugh, and thank you for attending. Have a good rest of your day.